The growing peril of space junk, a silent crisis above us. In the pristine vastness of outer space, a silent crisis is unfolding, one that could have profound implications for future space missions and the safety of satellites orbiting Earth. This crisis is the ever-increasing problem of space junk, also known as space debris. Comprising millions of pieces of defunct satellites, spent rocket stages, and fragments from collisions or disintegration, space junk poses a significant threat to space operations and is becoming a pressing concern for governments, space agencies, and private entities involved in space activities. The origin of space debris can be traced back to the dawn of the space age in the 1950s. Since then, every space mission has contributed, in varying degrees, to the accumulation of debris in Earth's orbit. Notably, the first significant increase in space debris was observed in 2007, following an anti-satellite test conducted by China, which generated thousands of new debris particles. This was further exacerbated by the accidental collision between an inactive Russian satellite and a functioning Iridium communications satellite in 2009, leading to a dramatic spike in the amount of debris. The dangers posed by space junk are manifold. Even small pieces of debris, often no larger than a fleck of paint, can travel at speeds of up to 28,000 km per hour, endowing them with the potential energy to cause significant damage to satellites or spacecraft. This risk is not just theoretical. There have been numerous instances where space debris has collided with and damaged space assets. The International Space Station, ISS, for instance, has had to perform several maneuvers to avoid potentially catastrophic collisions with debris. The problem of space junk is exacerbated by the Kessler syndrome, a scenario proposed by NASA scientist Donald J. Kessler in 1978. It describes a self-sustaining cascading effect, where the density of objects in low Earth orbit is high enough that collisions between objects could cause a chain reaction, each collision generating space debris that increases the likelihood of further collisions. This domino effect could render some orbital regions unusable for decades or even centuries. Tracking and monitoring space debris have become a significant activity for space agencies worldwide. The United States Space Surveillance Network, SSN, for example, tracks more than 23,000 objects in Earth's orbit. However, it is estimated that there are hundreds of thousands, if not millions, of smaller, untrackable pieces of debris that pose an equally significant threat. Addressing the issue of space debris requires a multifaceted approach. Mitigation efforts are centered around minimizing the creation of new debris, such as by designing satellites and rockets to minimize the risk of in-orbit breakups, and ensuring that defunct satellites are deorbited or moved to a so-called graveyard orbit. Furthermore, several organizations and companies are exploring active debris removal (ADR) concepts, which include ideas such as nets, harpoons, and robotic arms to capture and remove large pieces of debris from orbit. International cooperation is crucial in this endeavor. The Interagency Space Debris Coordination Committee, IADC, comprising space agencies from 13 countries, has been at the forefront of developing guidelines for debris mitigation. These guidelines include recommendations like limiting the time spent in low Earth orbit after a mission's end, and avoiding intentional destruction of satellites. However, these guidelines are not legally binding, highlighting the need for more robust international regulatory frameworks. The commercialization of space and the increasing number of satellites deployed by private companies add another layer of complexity to the issue. Megaconstellations of satellites, such as SpaceX's Starlink, have raised concerns about increasing the potential for collisions and contributing to the space debris problem. This burgeoning commercial space sector necessitates updated rules and improved management practices to ensure the long-term sustainability of space activities. In conclusion, space junk represents a significant and growing challenge that requires immediate and sustained attention. It embodies a classic tragedy of the commons, where the shared space environment is at risk due to the activities of various actors. Addressing this issue effectively will require international cooperation, innovative technology, and a commitment to sustainable practices in space. As we continue to explore and utilize the final frontier, ensuring the safety and sustainability of our space environment is not just a matter of environmental stewardship, but also of safeguarding our future in space.